Good day, everyone. Welcome to Marinay's Powerhouse Team Review and Training Center. My name is Engineer Reggie and Marinay. So you can call me Kuya Reg for short. So we are here to discuss direct current circuits part 18. So this is actually part 2 of our topic, dependent sources. So let us go to our problem. Okay. Last time we discussed this example problem, no? Today we are going to discuss this in a different approach, no? In a different way of solving this problem. Okay? So, let us, I will draw first the given circuit on the board. I will redraw the circuit. Okay, so, well, you can copy while I am writing on the board. So, in your screen, so, already there, the circuit shown. Okay, so we have 2 ohm resistor. Then we have another 2 ohm resistor. Then we have a dependent current source here. Okay. So our dependent current source is V over 4. V over 4, which is actually the voltage drop in the 2 ohm resistor. Okay. Then we have a 12 volt source here. Then positive, negative. Then we have a current I flowing. Okay. So here's now the electric circuit. So in the circuit shown, so we are asked to find the value of our current I here and our voltage V. So this is our voltage V. That is the voltage drop in the 2 ohm resistor. Then we have here what we call a voltage dependent current source. Okay. So I'll show you a different approach for this particular problem. Okay. So last time we used the Millman's theorem in this problem, but this time I'll be using the Kirchhoff's current law. So take a look here, guys. So I will assume a certain current here. Let's say we have a current I sub 1. Okay. Let's say I will assign this as node A by Kirchhoff current law. Kirchhoff current law at node A. Okay, so let's take a look here at node A. Our current is equivalent to the current equation, so we have here our current I. The current entering is equal to the current leaving. So the current entering is I. Then plus, so this is a current that is V over 4. So we have plus V over 4. The current entering is equal to the current leaving. So the current leaving here for this case, that is our I sub 1. Okay? So ito yung I sub 1 natin, mga pa. Okay, so yung I sub 1 natin, we have our I sub 1. Let us get the equation for I sub 1 in terms of our voltage drop B and the 2 ohm resistor. Okay, I'll discuss this in detail. So let's say this is our 2 ohm resistor. Okay, and then we have a voltage drop. If you see this circuit, it has a V, it has a positive and negative, meaning we have here a voltmeter that will simply measure the voltage drop across the 2 ohm resistor. So the current I sub 1 here is this current. That is the current flowing in the 2 ohm resistor. Okay? So this is positive. Okay? That is the positive terminal of the voltmeter. And then the negative is, this is also the negative. Okay? So let us use by the powerhouse let it flow method. Let it flow method. Okay, what does it mean? Okay, so we have here our current I sub 1. Let it flow here, okay, following its direction. Okay, that one. So, following its direction, that is on a clockwise direction. So, we have here our I sub 1 will simply equal to, okay, the powerhouse let it flow method. Now, we call this as the PLM. The PLM, okay, is based on the Kirchhoff's law. So, I sub 1, if it lives on the positive terminal of the voltmeter, meaning that is a positive B. If it lives on the negative terminal, so meaning that that should be negative B. Let's say our current I sub 1 is going to the left, okay? The direction will be on a counterclockwise, wherein our B will become negative because if that is going to the left, so it will live on the negative terminal of this voltmeter. But in our problem, we assume that is going to the right. This will produce a clockwise rotation of our current I sub 1 here in our circuit. So this will leave the positive B, then divided by the resistance, which is 2 ohms. Simply 2 ohms. Okay? Well, here is the simple technique. So I just make it in a very detailed manner. So this is a simple technique. If you have a circuit, let's say, you have here your 2 ohms, then we have here our V, we have here our plus and our minus. If our I sub 1 here, see, that is entering, considering this is the voltmeter, that is entering at the positive of B, meaning that is positive B, positive B. If it so happen that this is negative, if that is negative, and then this is positive. So this simply means we have to make this B as negative B. Okay? If it enters on the positive, again, if it enters on the positive of the voltmeter here, this is the voltmeter, if it enters the positive of the voltmeter, that is positive B. Then, if it enters on the negative, this is negative and this will now become positive. If this current I sub 1 enters on the negative, meaning that should be negative B. Okay, is that clear? Okay, so let us continue. Let us just substitute our I1 in our equation here. Let's go back to our equation. So we have here I sub 1, I plus B over 4, that is equal to I sub 1. So I sub 1 simply equal to B over 2. B over 2. Okay? And then, let us transpose this B over 2 here. So I, that will become minus B over 2, then plus B over 4, that is equal to 0. And then, our I here will become what? Okay, so this is negative 1/2. Actually, negative 1/2 plus 1/4. Okay, that will become a negative 1/4 or negative B over 4. So that is equal to 0. So we now have our equation number 1 here. Okay? And then now, let us have another equation because we have two unknowns. So I will consider this loop known, we call this before as the super mesh. Okay? This will be our super mesh. We are going to consider this one complete loop here. Disregarding your current source. You are thinking that it is removed from the circuit. You are only thinking of this external circuit here, this one complete loop here. Let us forget this for the meantime, no? Kalimutan muna natin to. Mga ka-aware pa for the meantime, no? Okay? Okay. So, we have here, by Kirchhoff's voltage law, let's say let us consider at our super mesh. That is our super mesh. This one complete circuit. So, we have here now the equation. So, looking here, this is our circuit tracing. Okay, this is our circuit tracing. As we see here, remember that this is current I. The current I is also the current here. That is our current I. Okay, looking at our circuit tracing, that is going upward also. Okay, they have the same direction. Again, if this is the current is upward, the circuit tracing is upward, we only have one direction. So therefore, one line. Okay? One direction, one line. So we have here one line. So the voltage drop will be 2I. That will be 2I. Okay? For this portion. What about this portion? For the 2 ohm resistor here. Okay? So looking here, okay? Looking here. So, let us consider our voltmeter. So, this is our voltmeter. This is our circuit tracing. If our circuit tracing, here, the circuit tracing, it lives on the negative terminal of the voltmeter, no? Ibig sabihin, dun siya lumabas sa negative terminal. If the circuit tracing lives on the negative terminal of the voltmeter, so meaning that should be negative. Okay? That should be negative B. Okay? That should be negative B. So, just put here minus B. Minus B. Then, what about here for the 12-volt source? It lives on the negative terminal of the 12-volt source. So, that should be negative 12. So, negative 12. So, that is equal to 0. Okay? So, now, we can have the equation here. Let us transpose negative, negative into positive. So, this is negative 2I. Let's transpose here. So, that will become a positive 2I. Negative B, transpose, that will become positive B. That's equal to negative 12. So, that will be our equation number 2 here. Okay? So, we are now ready, no, to use our calculator. Put your calculator in mode 5.1. Okay? That will be mode 5.1. Okay. Okay, so let us have here mode 5.1. Okay, take a look at our equation number 1. There is numerical value here. Numerical coefficient of 1. So that should be 1 equals, then negative 1/4. 1/4 equals, then we have here 0 equals, then for our equation number 2. So we have here 2 equals, we have here 1 equals, so we have here negative 12 equals, then equals. Then you will get now your x. Your x here is actually our I. So our I here will be equal to negative 2 amperes. Okay? Let us press another equals in our calculator. So that will be our V. because our x is the first variable here. The first variable is I, that will be our x. The second variable is v, that will be our y. So our v here will be equal to negative 8 volts. So that will be our answer. Okay, that one. Okay, so therefore our answer would be letter. Okay, so yan mga kawerpa, ang sagot natin negative 8 volts and 2 amperes. No? So, well, again, what do we mean by negative current? Meaning, the assumption here of going to the right is wrong. That should be going to the left. Okay, what about now the voltage drop of negative 8 here? The voltage drop, meaning this positive must be replaced by negative. No? You have to interchange the polarity of your voltmeter. Okay? Okay, let's go on to problem number 2. Okay, problem number 2. Okay, find the current I. Okay, so let me draw first the circuit on the whiteboard. Okay, you may also redraw that in your notebook. Okay, we have an independent current source of 6 amperes. We have 8 ohm resistor here. Then we have 6 ohm resistor. Then we have 4 ohm resistor. For the current controlled current source is 3I. Okay, so we have here 3I. Then we have the node. We have 2 nodes here. Node 1 and node 2. So meaning we'll be using here nodal analysis method. Nodal method. We have the current I here. Current I. Okay. Okay. So let us have this. Okay. So we have here 2 nodes, node 1 and node 2. So basically, we have to introduce a voltmeter here. We have to introduce here a voltmeter. So let's say we have our voltmeter 1 and our voltmeter 2 here. Okay. So let's say this is our ground terminal. This is our ground. Okay. So let us put here. Okay. We have a voltmeter here. There. So we have plus, minus, plus, minus. Okay. Remembering our nodal analysis method. So it is based on the Kirchhoff Current Law. Okay. So I will put here. Okay. I will assume that this is current I sub 1. Okay. So this is our current I sub 1. Okay, so we have here let us have now the nodal analysis method by nodal analysis method. That is based on the Kirchhoff Current Law. So we have here our 6 ampere. No? Our 6 ampere, let us put it here. The current entering is 6 ampere. So let us put it here. Our 6 ampere here simply equal to I1. Okay, that is the current leaving. 3I is also current leaving. And the I here is also the current leaving. Okay, so we have here I1. Let's put here I1. So take a look here. We have here I1 plus 3I. So we have here another current leaving. We have our 3I. So we have plus 3I. Another current leaving is simply our I. Okay? Plus I. Okay? Let us have the equation for our I sub 1. Take a look here. Okay? We'll make use of the powerhouse let it flow method. Okay? I will give right away the equation for our I sub 1. Take a look. Let us forget for the meantime this dependent current source. Let us just think of this complete loop, one loop here. Let us make use of the PLM, the powerhouse let it flow method. Okay, so take a look here. I will consider this circuit. Okay, let I1 flows. No, let it flow. Let it flow. No, let I1 flow here. Okay, so if we are to let I sub 1 flow here, okay, it leaves on the positive terminal of B sub 1, right? So, put here positive B sub 1. And then, this I sub 1, it leaves on the negative terminal of B sub 2. So, that's why that should be minus B sub 2. And then, the resistance is simply 4 ohms. Where it's just simply the current is the voltage over the resistance. It's just a simple Ohm's law. Okay, so we have here, I will have first our I sub 1, which is B1 minus B2 all over B4. I will put it here, B1 minus B sub 2 all over 4, okay, for I sub 1, plus 3I plus I. This is actually 4I, plus 4I. Plus 4I. So that is equal to 6. Okay? That is simply equal to 6. Then take a look here for our I, by the way. This is our I. Take a look here. This is our I. Again, if I will put here the positive terminal of B sub 1, this is actually the positive terminal of B sub 1. And this terminal is actually the negative terminal. Again, just like what I've said before, if the current enters the positive terminal of the voltmeter, meaning it is positive B sub 1, that should be, what I mean is our I simply equal to positive B sub 1 over 8. That is the voltage drop here in the 8 ohm resistor. No? So that is positive B sub 1 over 8. So I will just substitute B1 over 8 here. So we have here B1 minus B sub 2 all over 4, then plus 4. What is again our I? Our I is B1 over 8. B1 over 8. That is equal to 6. Okay? That is equal to 6. So, let us simplify this. So, we have 4 here. Okay? We have 4. Then, we have our 8 here. So, that should be 2, right? That should be 2. Okay? So, if that is 2, okay, I want to make it as simple as possible, this equation. So I will multiply both sides by, okay, I will multiply it by 4, both sides. Okay, so that will become what? So the 4 here will be cancelled out. That will become B1 minus B sub 2. What about here in this equation? So that will be 4 over 2. It's simply plus 2. Okay? That should be plus 2 B sub 1. So that is equal to, what about here? 4 times 6. So that is 24. Okay, let us simplify. So we have here B sub 1. We have another B sub 1. So 2 plus 1. So we have here 3 B sub 1. Minus B sub 2. That is equal to 24. So we have our equation number 1. No? We have our equation number 1. Okay. So, that is our equation at node 1. No? That is at node 1. By the way, at node 1. What about at node 2? Okay. What is our Kirchhoff Current Law equation at node 2? Okay, so we have here, take a look. We have a node 2 here. Let us put now the dependent current source here. And then, we have here, guys, I will make this as our I sub 2. I sub 2. Okay, again, by Kirchhoff Current Law, the current entering here is our I sub 1. That is our I sub 1. We have our I sub 1 here. I sub 1, current entering. We have here 3I, another current entering at this node, plus 3I. Current entering is equal to the current leaving, which is our I sub 2. I sub 2. By the way, what is our I sub 2 here, guys? Again, just the same. So, our I sub 2 is the current here. That is the current leaving at the at node 2. That will simply enter to the positive. Okay? So, this is the positive terminal. This is also the positive terminal of the voltmeter. So, our current I sub 2 is this. So, this will enter to the positive terminal of the voltmeter. Therefore, that is positive. Okay? So, well, I can just put it here. I sub 2. Okay? So, that will be what? V sub 2 over 6. V sub 2 over 6. Okay? So, wherein our I sub 1, we already have the equation for I sub 1. Our I sub 1 is V1 minus B sub 2 all over 4 plus 3I. Okay? Plus 3I. Wherein our I is simply B1 over 8. B1 over 8. Okay? Our I is B1 over 8. So that will be equal to I sub 2. I sub 2 is B2 over 6. B sub 2 over 6. Okay, let us simplify this equation. We can simplify this. So, by algebra, so we can have here, well, we can go directly with our calculator here. As shown here, okay, put your calculator in mode 1, guys. Mode 1. Mode 1. Okay. So, our B sub 1 here has a coefficient of 1/4. So, put here 1/4. Here. Please close up this portion. Okay, this portion. Okay, so we have here 1/4. 1/4 here, then we have here minus. By the way, this is 1/4. Okay, this is b sub 2, no? So we have to consider first all the b sub 1. So this is 1/4, then plus 3 over 8. So we have here plus 3 over 8. Okay, there. So we can now get equals. So this is 5 over 8. That is the answer here. This will become 5 over 8 b sub 1. B sub 1. Okay. What about now for b sub 2? Okay. For our b sub 2 here, that should be negative 1/4 by algebra. So that is negative 1/4. Okay, negative 1/4. Then b sub 2, this is positive. We have to transpose this. So that is why that will become negative. No? That should be minus. That should be minus 1 over 6. 1 over 6. So that will be equal to negative 5 over 12. So this should be negative 5 over 12 b sub 2. That's equal to 0. So now we can have now two equations. So we can now solve this using our mode 5.1 in our calculator. Press our calculator, mode 5.1. Again, looking at equation 1 and 2. So we have mode 5.1. So we have here 3 equals. We have here negative 1 equals. We have here 24 equals. So we have here 5 over 8 equals. So we have here negative 5 over 12 equals. Then we have here 0. We have 0 equals, then equals. So our x, which is our v sub 1, our v sub 1 here simply equal to 16 volts. Another equals that will give us our v sub 2, that is 24 volts. So what is the question in our problem? The question is find the value of I. So the value of I is simply equal to, again, our I is B1 over 8. Our B1 is 16 over 8. So therefore, our answer is simply 2 amperes. Okay? 2 amperes. There you are. Okay, the answer would be letter C. No? Very easy. Okay. So, we have to solve the next problem. So, I will erase first the board. So, you can copy for the next problem. Okay. For number 6. number 6, we are asked to find the Thevenin's voltage at point A and B. So here's now the problem. Okay, so the question is, what is the Thevenin's voltage at terminals A and B? Okay, first, we have a current I here. This is open circuited. So if this is open circuited, there will be no current that will flow here. So wala pong kuryenteng dadaloy dito. The current here is simply 0. So our current I here will just be flowing continuously on this loop. Okay? There. Okay, let us apply by Kirchhoff's voltage law. By Kirchhoff's voltage law. So it lives on the positive terminal of 2i. So therefore, it is positive 2i. This one. So positive 2i. What about the current here in the 6 ohm resistor? Well, actually, the current in the 6 ohm resistor is also our current I here. So that should also be current I. So parehas lang siya dito, mga kawerpa, no? Paikot-ikot lang to, yung kuryente na yan. Because the current I here is simply 0. Okay? So, we have here, the current I is going to the right, the circuit tracing here is going to the right. So therefore, only one direction, one line. Okay? One line. So therefore, that should be minus 6i. What about for the 12 ohm? The current I in the 12 ohm is going downward. The circuit tracing is also going downward. So they have the same direction. One direction, one line. If they are opposite, that should be two line, which means that should be positive. Okay, so that will be 12i. So that is equal to 0. Okay. So as we see here, take a look here, guys. We have here 2, so that is negative 6. That is negative, that should be negative 18. Negative 18 plus 2, that should be negative 16, right? Should be negative 16. I, that is equal to 0. Anyway, it's obvious that current I will be equal to 0 only. That is only 0. Okay? We have to take note that if we have a dependent source here, there is no current that will flow. That will flow here. There is no current. So therefore, our voltage at AB, our BAB will just equal to 0. That is our BAB. But it is not absolute 0. No? It's not an absolute 0. It simply means, no, this current, because that is 0, 0 times 12, that is the voltage drop here at AB, that is simply 0. We have to take note of this. Okay. So, we have to introduce a current source. Okay. A 1 ampere current source here. Let us introduce a current source here. 1 ampere. 1 ampere current source. We have to take note that our VTH, okay, our VTH or RTH, I mean, that is the Thevenin's or the Norton's resistance, they are just equal, right? It is simply equal to the Thevenin's voltage, okay, then over the Norton's current. What is Norton's current, by the way? The Norton's current is simply equal to the short circuit current. That is our short circuit current. Okay? So, yun din yung short circuit current natin, mga kawerpa. No? So, we assume that our short circuit current, okay, we assume that we short-circuited our terminals A and B. So, there is a current flowing here of 1 ampere. So, we put the 1 ampere current source here. 1 ampere. Okay? If we consider this 1 ampere, there will be a VTH here. If we are to take a look at this circuit, I will not make use of the nodal method here. I will make use of the Millman's theorem. Okay, by Millman's theorem. Okay, take a look here. So we have our VTH here. Actually, that is also the voltage at AB. Our VTH is simply equal to what now? Take a look here. This is a voltage source, although it is a dependent voltage source, current-dependent voltage source. So, treat this as a voltage source, no? Just like an independent voltage source. So, just simply that we have a 2i here. The value is in 2i. So, we have here 2i. Okay. Then, that should be over what? Now, so 2i, that is over the 6 ohm resistor because we are using the Thevenin's. That is the short circuit current, no? That is the voltage over the resistance. What about here? That should be 0. There is no series voltage here. That should be 0 over 12. Okay? What about for this portion? Actually, they have 3 branches. There are 3 branches here. What about in this portion? We said if the current is upward, that should be positive. So that is positive 1 ampere. What about now for the conductance? No? Summation of the short circuit current all over the summation of the conductances. So that should be 1 over 6 plus 1 over 12. Because of the 6 and 12 here. So, oh, by the way, we have current I here. We have current I. This is our current I. What is our current I here, by the way? Take note that this is our VTH. Again, if we are to consider one complete loop, I will make use of the powerhouse let it flow method. So our I is equal to, simply equal to what? Let it flow here. That should be positive VTH, okay? VTH divided by 12, okay? Divided by 12. So let us simplify this portion, okay? This portion, let us simplify this. Okay, so we have, I'll just highlight this portion, okay? Wherein we have here, we have to cancel this one. This will just be 3, right? That will only be 3. Okay. So our I, what is our I over 3, by the way? So our I is VTH over 12. But there is 3 here. Well, that is over 1 actually. So, what is the extremes over the means here? So, that will be equal to what? Now, extremes, VTH, times 1, simply VTH. 12 times 3, simply 36. So, we have to replace the I over 3 here by VTH over 36. So, our VTH, that is equal to VTH over 36 plus, well, anyway, this is just 0, then plus 1. So, we have 1 over 6 plus 1 over 12. So, that is 1 over 6 plus 1 over 12. That is actually 1/4 only. That is just 1/4. 1/4. Okay? We can shift solve this. What will be the value of our VTH, guys? Okay? So we have to press the alpha, close parenthesis, so that this will become x, variable x, then alpha calc. Then we have to press the fraction, variable x, then over 36, then plus 1, then all over 1/4. Okay? So I just replace the VTH by variable x. So that will be the unknown in our calculator. Okay? Then shift calc equals. The answer would be 4.5. 4.5 volts. So this will be our answer, guys. Okay? And that will be letter. What letter is this? Anong letra yan? Okay, that is letter C. There's a follow-up question for number 7. For number 7, okay, what is the next question? Ano ang kasunod na tanong natin? Find the RTH. RTH is simply equivalent to RN. The Nortons and Thevenin's resistance are just the same. So, we have here our RTH. So, it's simply equal to, by Ohm's law, so that will be VTH all over the Norton's current, or this is actually our short circuit current if we are to short the terminals A and B. So, well, it is simply, the VTH is 4.5, and we assume that there is a current of 1 ampere here, or just simply 4.5 ohms. That is the answer, and that will be letter. That is just letter A, guys, no? So, yun din yun, 4.5, that is in ohms, no? Remember that if there is no independent voltage source here, the current here is just simply 0, no? 0 lang yun, mga kawerta, no? So, pag wala yan, okay? That is just simply 0. The current here, I mean. So, if we have a dependent voltage source here, this current I is just 0. Okay. Let us solve another problem. Okay, determine the voltage V. So, I will draw first the circuit, guys. Find the voltage V. Volts, then we have 4 ohm resistor. Then we have a independent current source of 4 amperes going upward. Four amperes. There you are. Okay, then we have 4 ohm resistor in parallel with the 4 ampere current source. So we have 4 ohms here. And we have a voltage drop in the 4 ohms. That is our V. So we have positive and negative. So we have a dependent. That is a current-dependent current source. Okay? So that is 4I. That is 4I. Okay? So that is going to the right. So it depends on the current here. Our current in the 4 ohm resistor here. So, meaning our 4I here, the I here is this current. It depends on the value of this current here. Then, what about the rightmost resistor? What's the value? 6 ohms. Okay. Guys, you will see here that let us consider this as a node here, this one. We will make use of the nodal analysis or the Kirchhoff Current Law here. I will consider here this, let's say, as node A. As node A. Okay? That is our node A. There is a current entering here, which is our I, our 4 ampere. Then there is a current leaving of 4I. Then what about here? I will assign the current here, guys. I will assign the current here. Okay? We can say directly that this current has a value of what? It enters on the positive of B, so therefore that should be B over 4. So we can go directly. We can use directly B over 4 here. So that it will just simply reduce the equation, guys. Huh? Okay? So, let us have now. No? Let us have this. The current entering by Kirchhoff Current Law. Kirchhoff Current Law at node A. At node A. Take a look here, guys. The current entering is simply our I. Okay? The current entering is simply our I. And also our 4 ampere plus 4. And the current leaving is what now? 4I. Okay? 4I. That is our 4I. Current leaving and also this B over 4. Plus B over 4. Okay, question. What is our I now? What is our I? Okay. So, we can simplify this first. No? We can simplify this first. So, we have here 4I. 4I, that will be minus I. 4I minus I. Okay. So, plus B over 4. B over 4. Okay. And then, so that is simply equal to 4. Huh? Simply equal to 4. So, 4I minus I simply equal to 3I plus B over 4, that is equal to 4. Okay. We should have another equation here, guys. No? We should have another equation. So, take a look here. This is simply a voltmeter, right? This is just a voltmeter. This is the negative. This is the negative of the voltmeter. That is also, we can also put the terminals here, right? So, we have here another voltmeter. We have another voltmeter here. So, the another terminal, I mean. So, this is the positive terminal of the voltmeter. And also that is the voltage here, just the same, no? you can put the positive terminal here at node A. Parehas lang yon, no? So, there is a voltmeter B here. Okay? Can we transfer the voltmeter here? Yes or no? Yes, because they are just connected in parallel. So, we can put here our voltmeter B. We can put it here. Okay? There you are. So, we have here a positive and a negative. We can make use of the powerhouse let it flow method here to get the current I. Let it flow here. This current is going to the right. Let it flow here. Remember, consider only one complete loop. There you are. What is now the equation for current I? That is equal to positive 12 minus B all over 4. Right? Okay? So, I will substitute it here directly. Okay? So, again, that is what? 12 minus B. That is 12 minus B all over 4. Okay? So, I will just simplify this further. Okay. Let us make use of our calculator. Okay, our answer here for V simply equal to 10 volts. 10 volts. Okay? That is the answer. Okay, therefore, our answer would be letter. Okay, anong letter? Okay, that is letter C. No? So, that is our topic for today. That is our dependent sources. Okay, so that's it for today. I'll see you on the next video. Thank you very much. God bless you all.